Chapter 3, Section 3, the unit circle and circular functions. In this section, what we're going to do is we're going to be working with the unit circle some more, and just remember when we're dealing with the unit circle, R is always going to be 1. R is always going to be 1. And so we've already discussed sine and cosine in terms of an ordered pair. And so I just wanted you to remember that when we talk about sine, we're talking about the y-coordinate of the ordered pair. And when we're talking about cosine of an angle, we're talking about the x-coordinate of an ordered pair. Remember, arc length is known as S. We discussed that as well. And so when we talk about sine of S, you're going to get the y-coordinate. Cosine of S is going to be the x-coordinate, and tangent is going to be sine over cosine, so that's going to be y over x. And then, of course, you have their reciprocals. Okay, so this is the unit circle, and this is found on page 119 in your book, so you can use that as a reference if you need to. But basically what the unit circle does is it relates our degrees, our radians, and our ordered pairs along the unit circle. And so we can easily remember these the unit circle conversions. For example, here it says, using the unit circle, find the exact circular function value for each of the following. So if we have sine of 5 pi over 6, sine of 5 pi over 6, well, we know that sine is the y-coordinate, and if we know that 5 pi over 6 is the same as 150 degrees, then we also know that the y-coordinate for sine of 5 pi over 6 is 1/2. So sine of 5 pi over 6 is 1/2. Now, what if we don't have the unit circle to fall back on? Well, again, we can do multiple things. We can change 5 pi over 6 to degrees, so you have 180 over pi. And so pi cancels out. And of course 6 will go into 180 30 times, and so we have 5 times 30 is 150 degrees. Well, we also know that 150 degrees has a reference angle of 30 degrees, and so that takes us right back to our 30, 60, 90. So we have 1, radical 3, 2. So it takes us back to our 30, 60, 90. And we know that sine of 30 degrees is opposite over hypotenuse, which is 1/2. So our reference angle is 30 degrees, and we know that sine of 30 degrees is 1/2. Now, we also know that in quadrant 2, sine is positive, so be careful with those signs. Remember which quadrant you're in, and so on and so forth. So you know that sine is 1 over 2, and you know that cosine in quadrant 2 is negative, and so this technically is negative radical 3 over the hypotenuse of 2. So let's look at cosine of 5 pi over 3. 5 pi over 3 is going to be here, so we're at 300 degrees. We're in quadrant 4, cosine is positive, and cosine is your y-coordinate, so it's going to be 1/2, positive 1/2. So cosine of 5 pi over 3 is 1/2. And then we have tangent. Tangent of 7 pi over 4. Tangent of 7 pi over 4 is going to be 315 degrees. But remember, tangent is going to be your sine over your cosine, and so that's going to be negative radical 2 over 2. That's your sine, that's your y-coordinate, over your x-coordinate of radical 2 over 2. And of course, anything over itself is 1, so these cancel out to negative 1. So tangent of 7 pi over 4 is going to be negative 1. We're in quadrant 4. Tangent is negative in quadrant 4, so that should make sense to you. Now, again, do I have to memorize this whole entire unit circle? Absolutely not. If you can relate what we've been doing to degrees, reference angles, and your 30, 60, 90, or your 45, 45, 90, for example, for the last one, then that's fine. Another thing, another hint that I told you is if it has a denominator of 3, then it has a reference angle of 60. And if it has a denominator of 4, it has a reference angle of 45. And if it has a denominator of 6, then you have a reference angle of 30. So that may be a way that you can remember it as well, and then relate it back to your 30, 60, 90. Okay, so let's look at this one. When you have sine of negative 2 pi over 3, sine of negative 2 pi over 3, that's negative rotation. And so when you're talking about negative rotation, remember you are rotating clockwise. And so remember, if it has a 3 in the denominator, then we are talking about 60-degree reference angle. So let's look at this. This is going to be your negative pi over 3 because it's the first one that I come to that has a 3 in the denominator. So this is going to be your 1 pi over 3, negative 1 pi over 3. This is going to be negative 2 pi over 3, which is what we're needing. So negative 2 pi over 3, if we're looking for sine of negative 2 pi over 3, sine of negative 2 pi over 3 is going to be negative radical 3 over 2. And again, you ask, well, what if I don't have my unit circle in front of me? What if I don't know that negative rotation? Again, you can always change this to degrees. And just remember that you're going in negative rotation, and then relate it to your 30, 60, 90. Also, again, I told you that if you have a denominator of 3, then you're going to have a reference angle of 60. Know that you're in quadrant 3, and sine's going to be negative, and go off your 30, 60, 90 triangle. So there are ways around not memorizing the unit circle. Alright, cosine of negative pi over 4. Cosine of negative pi over 4, again, that's negative rotation. Pi over 4 is a 45-degree reference angle, and here's your first negative 1 pi over 4. Negative 1 pi over 4. Cosine is your x-coordinate, so we're going to have radical 2 over 2. Okay, so let's look at this one. You have tangent of negative 11 pi over 6. So when you do that, we know that we're talking about 30 degrees. So we have to count every 30 degrees. So here's one 30 degrees, your first 30 degrees. Here's 2. So that would be 2 pi over 6, which of course will reduce. Here's 3, 4, 5, 6, 7, 8, 9, 10, 11. So negative 11 pi over 6 is the same as negative 330 degrees. Tangent, again, remember, tangent is going to be y over x, so we're going to have 1/2 over radical 3 over 2, and then we have a complex fraction, so we would need to simplify that, and you can do what we call, when I have a complex fraction, I do skin over guts. So again, skin is going to be the outside multiplied together. 1 times 2 is going to be 2. Over guts is going to be the inside, so 2 times radical 3 is 2 radical 3. And of course you can simplify that to radical 3 over 3. Alright, so let's look at this one. This deals with our reciprocal functions. Concept's still the same. So let's look at 11 pi over 6. 11 pi over 6. Well, if we do, and it's positive rotation, so if we do 11 pi over 6, we're going to go all the way to here. So that's 330 degrees. Remember, cosecant is the reciprocal of sine. And so typically we would have the y value, but remember it's going to be 1 over the y value. And so it is going to be negative because we're in quadrant 4, so it's going to be negative 1 over your y value of 11 pi over 6, which is going to be 1/2. And don't get those negative signs confused, so watch this. the negative signs take care of themselves when you're talking about these values. So cosecant is going to be 1 over sine, which is going to be 1 over your y coordinate, which is negative 1/2. So that's why you are going to get a negative, which is correct. Alright, so again, if we do skin over guts, then you're going to get a negative 2. So cosecant of 11 pi over 6 is going to be negative 2. Okay, so let's look at secant negative 3 pi over 4. Again, that's going to be negative rotation, and so we're going to go clockwise direction and every 45 degrees. So here's 1, 2 pi over 4, and 3 pi over 4. So negative 3 pi over 4 is the same as 5 pi over 4, or negative 225 degrees. And so secant this time is going to be 1 over cosine, and we know that cosine is the x-coordinate, so we're going to have 1 over negative radical 2 over 2. And then again, if you simplify this, you're going to get negative 2 over radical 2, which of course is going to simplify to negative radical 2. Alright, so let's look at this one. Cotangent of 11 pi over 3 is going to be multiple rotations, and I know that because if I take 11 pi over 3 and I minus 2 pi, that's going to get me, minus 2 pi, that's going to get me to 5 pi over 3. And so that's what I am looking for. So it's a coterminal angle. So 5 pi over 3 and 11 pi over 3 are coterminal angles, so we can just work with the 5 pi over 3. Again, I know that because 2 pi is the same as 6 pi over 3, and I know that this has a 6 pi over 3, so it is multiple rotations. So let's work with 5 pi over 3. Again, 5 pi over 3 and 11 pi over 3 are the same coterminal angles, so it would give us the same answer. So cotangent of 11 pi over 3, which would be the same as cotangent of 5 pi over 3. Again, it's going to be cosine over sine. So cosine is going to be your x, and so you're going to have 1/2 over negative radical 3 over 2. And so if we do our skin over guts, we're going to get 1 times 2, which is going to be 2, and then 2 times radical 3, which is going to be 2 radical 3, which again is going to be negative radical 3 over 3. Negative radical 3 over 3. Okay, so let's look at this. This will be the last thing that we do with this unit circle for now. It says find the exact values of s in the given interval that has the given function value. Do not use a calculator. So we are going to be using the unit circle, and we don't need a calculator, but this time we are given specific intervals to use. So look at letter A. We're talking about from pi over 2 to pi. Pi over 2 to pi is going to be your quadrant 2. And so we're looking for an angle, the exact value of the angle S, where sine is going to be radical 3 over 2. Sine is going to be radical 3 over 2. So what we're going to do is we know that sine is the same as y, and we're going to look in quadrant 2 for a value that has a y coordinate of radical 3 over 2. And so we know that S is going to have to be 2 pi over 3. Okay, so let's look at letter B. Pi, we're in the interval of pi to 3 pi over 2. That's going to be quadrant 3. We're talking about cosine of a certain angle. And so if cosine is your x coordinate, we're going to look for an x coordinate of negative radical over 2, a negative radical 2 over 2. And so we have an x coordinate of negative radical 2 over 2 here. And so we're looking at 5 pi over 4. So S is going to be 5 pi over 4. Okay, so let's look at this one. This one we are in quadrant 4, so we are here, quadrant 4. It's talking about tangent, And remember, tangent is going to be your y over your x. Tangent is going to be your y over your x. And so we're looking for something that would simplify, a y over x that would simplify to negative radical 3 over 3. Or negative radical 3 rather. Well, the only two that are possibilities are these two, because these two are the only ones that have a radical 3. So our option is either going to be 11 pi over 6 or 5 pi over 3. And so to figure that out, we're going to do a test here. If we think it's going to be 11 pi over 6, well, tangent of 11 pi over 6 is going to be negative 1/2 over radical 3 over 2, and if we do skin over guts, we're going to get negative 2 over 2 radical 3, which is going to be negative radical 3 over 3. So we know it's not 11 pi over 6, so through process of elimination, we know that it's going to be 5 pi over 3, but let's make sure 5 pi over 3 is going to be negative radical 3 over 2 over 1/2. Basically, it's just the reciprocal, so we know it's going to be it. Negative radical 3 over 2 is going to be, or negative radical 3 times 2 is negative 2 radical 3. Getting in a rush here. Alright, so negative radical 3 times 2 is going to be negative 2 radical 3 over 2 times 1, which is going to be 2. When they cancel out, you get negative radical 3. So we know that S has to be 5 pi over 3. So be careful with that and know which angle we're talking about when it's giving you tangent or cotangent. Those would be the two that are kind of tricky, would be tangent and cotangent. Alright, so what I would like you to do is I'd like you to try these numbers on page 126 and 127. Bring them into class if you have any problems.